Hi everyone, my name is Rishabh and today I'm going to be talking about my Syslab project, which was PantrEYE, in which I developed a smart pantry using computer vision and smart processing. In this presentation, I'm going to talk about my motivations behind the project, what I wanted to achieve, and what steps I took to achieve these goals, and ultimately carry out the project. If you're interested in learning more, please feel free to email me or check out the GitHub page for this project, and I'll provide links for both of those in the presentation. Hope you enjoy! The problem I chose to address through my project was related to the Internet of Things. The Internet of Things connects everyday items to the Internet so they can send and receive data to make life more convenient for their users, like the Nest thermostat and the Ring doorbell. In recent years, devices connected to the Internet of Things have grown in relevance. However, in spite of the advancement of the IoT, pantries have been left behind, and so even while less important devices like toasters are gaining Internet connectivity, the pantry, an aspect of the kitchen accessed every day, is still left unconnected. This graph shows the rapid growth in the number of devices connected to the Internet of Things. You can see that by 2020, over 50 billion devices will be connected to the Internet. In light of this, isn't it surprising that such a widely used part of the kitchen, the pantry, still hasn't been modernized? In addition to the lack of modernization in today's pantries, I also have personal motives for working on this project. I personally often don't remember what runs out in the pantry or even what's in my pantry a lot of the times, which makes it difficult when something runs out and I need to get something from the store. Especially considering that I'm going to college, where I'll soon need to be able to effectively manage my own pantry, and considering that many of my close friends are in a similar situation to me, I feel that it's important that this situation is addressed and pantries are brought into the Internet of Things. So what exactly is needed? You might be thinking, what sorts of things would I even need in a smart pantry? So an easy way for people to track food items is the number one necessity of a smart pantry, so people can be alerted when food items run out and can understand what products they have in their pantry, what they don't have, and they can get quick access to nutrition facts about pantry items and more. The second important item that is needed is accessibility, so users can easily access the information they are looking for without having to put in much effort. Finally, internet connectivity with other IoT devices like smart home speakers is needed so that the pantry can finally be introduced into the modernized technological household. My proposal as to how I'm going to address the problem I posed is creating a visual processing system that uses a camera to observe what's in a pantry at certain times, noting the specific products and the prevalence of each. I plan to do this using visual processing methods including libraries like OpenCV, as well as writing Python scripts to provide and improve pantry functionality. Here's an overview of what I envision the system to look like. So initially there's going to be a camera input that's taken by the smart pantry system. That camera input will then be passed into a detection model. That detection model will detect barcodes on each product that's detected and also detect the logo for each product. After these logos and barcodes are detected, they'll be passed into the lookup code. This lookup code will use the barcode detected and the logo detected and search libraries for products that match these descriptions and be able to output those sorts of products. Now, after those products are outputted, then what we'll do is there'll be a tracking mechanism to track over time how the products in the pantry change. So if something goes missing, if something stays the same, and then ultimately be able to alert the user. My winter goal for this project, or the goal that I wanted to achieve before winter break, was to achieve simultaneous barcode and logo detection and classification in pre-existing photos. So these pre-existing photos are photos of food that already exist. They haven't been taken by my system. And so essentially this comprises the detection to the output stage of the system overview that we just went over. And fortunately, I was able to achieve this goal. So barcode detection for my project was conducted using the PyZBar library, and what this library does is it detects the bounding box coordinates of various barcodes and or QR codes. In my case, it was barcodes, and it decodes these barcodes using UTF-8. After that, it plots using OpenCV the bounding boxes of each barcode and also tells you which barcode corresponds to which image and bounding box. So this is an example of barcode detection that was carried out by my system. So you can see that PyZBar detected the bounding box of the barcode and was able to give me the barcode number that corresponds with it. Over here on the top, it says General Mills Cinnamon Toast Crunch. So that actually involves a little bit of lookup. So PyZBar doesn't do that. That's part of my next stage, which is lookup. But this is just an example to show the functionality of the PyZBar library in barcode detection by drawing that bounding box. So for logo detection in my project, I used the Google Cloud Vision API. So initially, I struggled with a lot of authentication issues with this API and framework because with the school server and the Google servers, and there was all sorts of different issues that I encountered, but ultimately I was able to work through them. And in the Google Cloud Vision API, I used the Google Logo Detection Client, which essentially has a huge library of logos, and after you pass in a particular logo, it detects the logo, what's going on, and also matches it with the corresponding product that it's related to. So this is an example of logo detection carried out by my system. Obviously, this is not a food or something that you would find in the pantry, but I just wanted to show the functionality of the logo detection system, and you can see how it was able to detect most of these logos in the image on the left. So you see Wendy's, Subway, Yoplait, Coca-Cola, all those sorts of different logos were detected by the system. So after the barcode detection and the logo detection stages of the project were carried out, I moved on to the next stage, which was the lookup system. So this was primarily focused on barcode lookup because it was very difficult to find a logo detection library other than the one that I found at Google. So the barcode lookup was carried out by the UPC database API, and this API, when you give it a barcode, it returns the name and the description of the object that corresponds to that barcode. So after the individual components of the project were completed, the barcode detection, the logo detection, and the lookup system, I was finally able to put everything together and get a strong basis for the whole PantrEYE system. So in this example, you can see an example of everything being put together. So you see how this is a picture of Cheetos, something that you could normally find in a normal pantry. And you can see how my system ran on two separate veins. There was the barcode detection and the logo detection that were put together. So you can see how in the barcode detection, it detected the barcode in the bottom right of the package. It correctly detected the number barcode, and using the lookup system, I was able to determine a name and a description of the product, which was super useful. And then on the other hand, there was the logo detection, which detected the Cheetos logo. So when you put these two together, the barcode detection and the logo detection for each object, it makes it very useful in tracking products and determining what is and what isn't in a pantry at a particular period in time. So after the software basis for the PantrEYE system was established, I moved on to the hardware part. And so that first involved a camera input. So for the camera, I used a Raspberry Pi camera module version 2 on a Raspberry Pi 4. So I was able to set this up completely. And the reason I use this camera is that it strikes a great balance between portability and image quality. So we want portability because we want users to be able to move it into a pantry wherever they want. And we also want a high image quality so we can get that detection of logos and barcodes, which we'll ultimately use in our system. So after this hardware was set up, I went back and I had to make some modifications to the program itself. So obviously the first thing I did was modify the code to include camera. And so that was done using the Pi camera library. So now after that, what I did was I had the program take pictures periodically, which is set by the user of the PantrEYE system. So say a user wanted to take a snapshot of the pantry every 2 hours, the user can input that initially, and then Pi camera will take a picture every 2 hours, which can then be passed into the detection system and the lookup system. After that, I added object tracking between scans. So essentially, like if something goes missing in a pantry or if, things remain constant, it will alert the user of what goes missing based on, oh, hey, in this scan, we had a particular product. In this scan, we don't. This is missing. We need to alert the user. And then finally, I had a basic Pi-based user interface. So essentially a basic user interface on the Raspberry Pi that users can use to get the data. So in addition to just the basic program modifications that I carried out to develop the system, I also took steps looking into the future relating to the Internet of Things and UI. So the first major part of that was I looked into Amazon Alexa skills. So most people are pretty familiar with Amazon Alexa, and what I wanted users to be able to do was be able to ask, hey Alexa, what's in my pantry? And then Alexa, using the Alexa skill I developed, would be able to tell users, oh, this is in your pantry and this has gone missing. And so I've begun an AWS implementation and an Amazon Alexa skill implementation for that. And so after that was I looked into Firebase. And so Firebase is a databasing tool that helps creators of applications store data. And so I wanted to be able to use Firebase to store past data so users can retrieve over time what their pantry has looked like and what they've had in their pantry. And so I've begun looking into that as well. And finally, I wanted to implement Flutter. So Flutter is an application development framework that you can use to develop apps for simultaneously both iOS and Android. You don't have to develop in Android Studio and then develop in Xcode again. You can just use Flutter and create a wonderful UI and a wonderful application that runs on both Apple and Android devices. And so I've begun creating an application for the PantrEYE system so that way users can easily just open up their phone, see what's in their pantry, see what's gone missing, and just have a really nice user interface for the project. So some future steps and goals of where I think this project will be heading is first, developing a more advanced UI and moving to mobile. So I talked about Flutter earlier. So that includes, finishing up that Flutter application and being able to push to mobile devices. After that, also, I would like to implement more thorough detection mechanism techniques. So instead of just logo and barcode, also maybe including shape detection or more advanced text detection to help identify items in the pantry. And then finally is the full-fledged Alexa skill so that the full IoT integration can be achieved, which is what this project was founded on. There's a lot of people I would like to thank for this project and like to acknowledge. So number one is Dr. White, who was my Syslab teacher. I had him for second period Syslab. Dr. White has been incredibly supportive throughout this entire process, and without him, I definitely would not have been able to achieve what I have achieved in this project. He helped me with technical difficulties, with ordering products, with just being there to support me throughout the project, and without him, it wouldn't have been able to be done. Additionally, I would like to thank my classmates. They helped me come up with ideas for my projects and what I can implement. They helped me find libraries and find tools, and they were ultimately also very supportive, just like Dr. White, in this entire process. I would also like to thank my parents and my family because they helped me additionally come up with ideas and also help provide me with products and a way for me to test my actual code. And additionally, I would like to thank future workers. So I hope that the project can be carried on beyond after the coronavirus pandemic, and we can really achieve those future goals that we hope to achieve. So yeah, thank you so much to all of these people, and I greatly appreciate your help in this project. So I wanted to thank you very much for listening and watching. Normally during TJ Star, this would be the part where I say if you have any questions, I'd be happy to take them. But since we're not at TJ Star, if you have any questions, definitely feel free to contact me. My email is listed right here. And I hope you enjoyed. Thank you.